when we have to set up our own equations, inequalities, no matter what, which one of those two it is, we are going to always describe what are our variables going to represent in the problem. And we're going to set up an equation or an inequality, whatever it is that is required for that problem. We're not working with systems right now, so we only have to set up one. Okay? So we have that problem here about the royalties for a high school play. Royalties mean for a high school play, Benton?
Expenses.
All expenses? Is that what you said?
Yeah.
Okay. It is an expense. Can we be specific about what kind of an expense it is? Anybody know what? If you have to pay a royalty fee, the drama department here has to pay a royalty fee. What are they paying for? So it is an expense, I agree.
How many people can be in?
Not necessarily how many people can be in it.
How much the people have to pay. I don't know.
Guess we don't know, huh? Okay. Give me an example of a famous play. Pardon? Hamlet? Okay. So somebody wrote Hamlet, right? They wrote that story. They wrote that play. They wrote that script. They have copyright to it. They own it. So for anyone else to use it, they have to pay what's called a royalty fee. So if the drama department wants to put on Hamlet, to get the rights to it, to be able to do it, they have to pay a set fee for whatever that they're going to charge. In this case, it says the royalties for this high school play, which we don't know what they're going to be putting on, are $400. The tickets to the play sell for $5 for students, $8 for adults. Again, I always say, look at the question you're asking to help you decide what X and Y should represent. What are the possible combinations of ticket sales needed to pay the royalties? Okay. Do we already know how much the tickets are going to sell for? What don't we know? So many, yeah. So what could we let X represent in this one? Number of student tickets. In fact, look at who set your graph up down here for you already. So what did I put on the x-axis? Student tickets. So we're going to say, let X be the number of student tickets. Then Y will be the what? The number of adult tickets. And we're coming out of working with systems of equations, so we're going to feel like we have to set up two of them, but we really only need one here because we are going, the information they gave us is what? What can we use to help us set up this one inequality, by the way, it's going to be an equation. Because it says, what are the possible combinations of ticket sales needed to pay the royalties? Well, there's also a possibility of not only paying the royalties, but having some extra money, right? To pay maybe some of the other expenses. So, what do you think we could use as an inequality for this one? Knowing that we know what the student ticket price is, we know what the adult ticket price is, we know how much they need. Go ahead, write something in your paper then. You don't want to talk to me, so go ahead and write it. You come up with something. And then I'll let Tate share his with you. Okay, are you ready, Tate? Okay.
400 less than or equal to 5x plus 8y.
I noticed that we forgot to answer this some other information that would be helpful. Need to make $400, or not $400, at least $400. We're going to say at least $400. Realize I had a spot there for us to write that. Need to make at least $400. Okay, so let's see if Tate's inequality works here. It says $400 has to be less than or equal to the amount of money you will take in with student sales, 5 times X, plus the amount of money you'll take in with adult sales, 8 times Y. Think that works? Okay. Anybody write it differently? Because there is another way we could easily write this also. Anybody have a different way? I always find it interesting that students start with the money amount. I never start with the money amount. Anybody else start, I mean, the $400 part, this whole thing is about money, I guess. 5X is about money, 8Y is about money. No? What if I started it like this? The amount of money I'm gonna take in with student sales, the amount of money taken in with adult sales, and I know I need to make greater than or equal to 400. The equal to will cover just the royalties, but I also could make more than that. Would that one work also? Is that the same thing, really? Anybody have it written that way? That's typically how my brain wants to do it. Okay, we gotta get this put into what? Slope intercept form. Okay, let's go. Which one do you want to work with? Should we work with Tate's over here? What are we gonna do? Either way, we're gonna kind of do the same stuff, but subtract 5x. So we have 400 take away our 5x. We did not do any multiplying or dividing, so we don't have to worry about switching the sign yet. And then, what's our next move? Divide everything by 8. Each piece gets divided by 8. So I have 400 divided by 8. I have 5x being divided by 8. And 8y being divided by 8. Okay? What's our inequality statement read now? 400 divided by 8 is 50. There are 8 50s in 400. 5 divided by 8. Is it a whole number? No, so we will just leave it 5/8 x. Do we need to switch our symbol? No, we did not divide by a negative, and now we have y alone. And again, if we would have solved the other one, it would have turned out like this. Y is greater than or equal to 50 minus 5/8 x. Okay, we need our m and our b. M is, b is. What's our m? Our slope? Negative 5/8. Negative 5/8 means you can go on the graph. What can you do? Down 5 and right 8. Or you can up 5 and left 8. You can only use the negative in one direction or the other. Okay, what scale up did I set the x-axis at? What are we going by on the x-axis? 5s. I've only labeled every 10, but we're going by 5s. Okay, so let's finish labeling that one. Because it's pretty worthless to us without doing that. Costs you points on an assessment when you don't do it. So the x-axis is going by 5 tickets at a time, every grid line. How about the y-axis? What's the y-axis doing? Same thing, going by 5s, okay? Get that one labeled up also. Now remember, when we have, a slope, when we have a scale that is different than going by ones on both axes, we want to take into account then that if we go down 5 and we go over 8, will we really be accomplishing what we need to according to the scale? Because that's going by basically by ones, okay? So let's first put our b value on the graph, which is 50. Okay, now let's make a decision. What should we do to make more points? If we go down 5, how many tickets are we going, how many adult tickets are we actually going down? If we go down 5, oh, I forgot to put my 50 here. If we go down 5, we're really going down how many adult tickets? 5 grid lines is, just say it loud enough for me to hear, that's all. If the scale is 5, and we go down 5 grid lines, how many adult tickets are we really going? Why is this so difficult? What's the deal here? If we go down from 50 to 45, we've gone down how many tickets?
5.
But that's only one grid line, right? 1, 2, 3, 4, 5. How many tickets did we really go down? 25. If we go, so we've used up our negative, if we go over 8, how many tickets are we really going over? 5, 10, 15, 25, 35, 40. Is 25 over 40 the same as 5 over 8? Yes. So it appears that we can still do the go down 5 and over 8. We have to make sure that they're equivalent. So when we go down 25 tickets and we go over 40 tickets, we're really still, or go down 5 and over 8, we're still really, that's 25 over 40, which is still 5/8. So now we can do it again to get our third point here. And we need some rulers. Would we have a dash line or a solid line? What kind? Solid, right? It's going to be solid. Because of the equal to bar. So if the equal to bar is included, we want to have a solid line. So we can include all the points on the boundary line. Get your boundary line drawn. Drawn. Does it need to go past the axes, or should it be a line segment? Yeah, because if we go into any other quadrants, we are starting to deal with some negatives. Can we have any negative tickets? No. So we're going to have a line segment only. Next decision, should we shade above or should we shade below? Should we shade above or should we shade below? We should shade, if I look at this one, it makes it easier for me to see. When y is on the left side, we can say is greater than, so we need all of the ones, all the y values that will be greater than, so we get a shade above. If we read it from this one, it makes it a little trickier. We're saying all the values that y have to be, you know, it's kind of like, or y has to be, this has to be less than all the values y has to be. So that one makes it a little trickier to follow. So let's, looking at that one, see that we need to shade above. So you need to shade nicely, even I don't have a stylus pencil that we let you do. Now here's how we're going to test by answering these questions, okay? When it's a word problem, we're going to test it by making sure that anything we grab from that region makes sense. It gives us what we know it should. So give a possible combination that would cover only the royalties. Give me an ordered pair, a number of student tickets and a number of adult tickets. That the only thing, they'd only make enough money to pay the $400 basically, the royalties. Where would those come from? The boundary line. Those come from the boundary line. So give me a possible combination. We got 3 very clear ones. Let's take the one in the middle. Let's go with this one. What's that one? 40, 25. Okay. So that means selling 40 student tickets and 25 adult tickets. And now we're just going to do some mental math to see. This is kind of like testing right now. The boundary line is what we're testing. So would they make exactly $400? If student tickets sell for $5, what's 40 times 5? 200. Adult tickets sell for $8. So he's selling 8 times 25. 8 quarters is $2, 200. 200 plus 200 is 400. Looks like we have a good boundary line anyway. Okay. Now we're going to check. We're going to say, what do the combinations in the shaded region provide? What do they actually provide? If we pick an ordered pair from the shaded region, what would that tell us? What would that give us? That would give us that they made more money. They made more than $400. So let's just pick one and do a mental math check here. Let's find one where we have some intersection of grid lines. How about 50 and 50? How about that one right there? That's from the shaded region. That means they should make more than $400. So remember, student tickets sell for $5. It was 50 times $5. $250. adult ticket seller, $8. What's 8 times 50? 400. So we have $250 plus $400. How much money did they take in? $650. So they covered the royalties and made an extra $250. Okay, what are the recombinations in the unshaded region represent then? Pardon? Yeah, they didn't take enough in. Sentences, we're getting practice writing your sentence answers again. So again, I'm just going to pick one. I'm going to pick 10-10 right here. It's in the unshaded region. Well, student ticket sell for $5. 10 times 5 is $50. 10 times 8, $80. 50 plus 80, $130. Not even close, right? Okay. So any questions on our application problem and what you should do to show and how you should answer questions they ask you, etc. Okay, let's go to the back side then, because this is where now you're going to have to be able to write an inequality for they give you the solution basically is what they're saying. Here's the solution, here's the graph. We've already solved it for you, but you tell us what the inequality is that came from, okay? So what I say is follow this process. If you determine the slope and the y-intercept of the boundary line, that's going to help you be able to set up basically the equation for the boundary line is what that would help us do. Determine an inequality symbol because it can't be an equation, it's going to be an inequality. So we determine the inequality symbol according to the type of boundary line, because if it's dashed, what should not be included in our inequality symbol? The equal to bar. If it is solid, the equal to bar should be there. Shading, we know something about shading also. If it is greater than, where should it be shaded? Above. If it is less than, it should be shaded below. Okay, so let's go to this first one here. Let's decide, I think it's sometimes easier to, first of all, decide what's the b value. So this starts at 1 on the y-axis. So our b value is 1. Pick another ordered pair that you can clearly tell that it has integer x and y coordinates. So I'm going to pick this one up here because I can see that it's at the intersection of two grid lines. So I basically have a slope of going up 3 and over 1, so the slope is what? Positive 3. Okay, so now that I know that much, that's going to help me do my m in front of my x and my plus b part. Okay, next thing I'm going to decide is what kind of line is shown on the graph, dashed or solid. Colin? Save your coloring for when you do your homework, okay? It's a dashed line on the graph, and it is shaded above or below. Is this shaded above or below? Below. When it's got a really steep slope, kind of imagine tilting it a little bit so that you can make a determination. Sometimes it's hard to, okay, tell that. Okay, so what inequality symbol will be used for dashed and below? Just is less than. We are ready to write our y is less than 3x plus 1. Now what I want you to do is put that in your graphic calculator. Let me show you how to do inequalities on your graphic calculator. We're going to make sure it matches that picture. So go to your y equals screen, clear out anything that's in there, please. Y equals screen, clear out anything that is in there right now. In y sub 1, put 3x plus 1. After you have your 3x plus 1 in there, the next thing that you do is you stay on that y sub 1, and I'm just going to have it so that I make sure I'm leading you in the right direction here. Use your arrow to the left key. Use your arrow to the left key until it gets on the far left, and you'll see it kind of like flashing in that line going kind of up and down. Everybody over in the far left column. To the left of y sub 1. Okay, now I want you to press your enter key. Okay, that's not what we want yet. Press it again. See what's flashing. Looks like a half plane that is shaded. Would that be an above or a below, do you think? above. We want a below. So we're gonna press enter again. And now we're gonna press zoom 6, so we get a nice standard graph. And we should get a picture. Does it look like the one we have that we were writing the inequality for? Did we do well?
Yeah.
Okay, let's turn it off for just a bit here. And let's move on to our second one. You go ahead and do that one. You figure that one out. What do you think is the inequality statement for that graph? Remember, the first thing you're going to do in step 1 is you're going to decide what M and B are. And then in the next one, you're going to decide what inequality symbol by just answering questions about the line and the shading. And then you will be ready to write your inequality statement. After you think you have yours, you're convinced you're right, go back to your graphing calculator, check it out. Go to y sub 1, take out the one that you had in there, put in yours. And see if you get a match. Remember how you put a fraction in parentheses around the, you do the numerator divided by the denominator. This is a nice decimal. You could also use the decimal name. Anybody have the same inequality statement I do? Okay, check me out. Am I right? In other words, does it match the graph? Now, the only part of the graph, these graphing calculators can do, I'm sure the newer ones can now, is the dash and the solid line part. It's just going to draw a line. It's not going to do this dash or solid part. Okay? If you have that one, move on to the last one. See if you got that one then too. You can figure out the last one. Check it out in the graphing calculator here. Hopefully your brain is still doing what I taught you to have it do when we were graphing these lines. If the slope is positive, it better be rising from left to right. If it's a negative slope, it better be falling from left to right. Got it? Once you have checked your last one, you may get your graphing calculators. Would you clear out your y equals screen, and then you can get the graphing calculators turned off. We're just put back in the certificates. Yes, Gail.
Question about the graph.
Okay. Okay, anybody have any questions on these last two that I kind of set you loose on your own for? Okay, and I'll come back there and tell me you can. Okay, and I will get your graph handout out to you.